This was originally all supposed to be one video, like 3 hours long. I showed mercy. Hey, welcome back to Frank's Modelworks. I'm Frank. It really was supposed to be one episode, like 3 hours long. And even I was like, that's a bit much. So I'm going to break it up into more than one, several videos. But I do want to explore the topic as much as possible because I really do think that this is going to be the future of the hobby. Now, last time we spoke about this, I brought up the fact that there are merchants that are currently engaged in providing scale modelers in the model car community with really, really nice 3D printed parts. And I mentioned Joel Mendoza from Iceman Collections, Joseph Osborne from Fireball Modelworks, Matthew Inman from MCV Products, and Josh Reese from VCG Resins by Reese. And I said that I was going to, be also looking into other merchants and buy some stuff from them and make recommendations as time goes on. But I just wanted to make sure that you understood. The two things, 3D printing yourself and buying from these merchants, are not mutually exclusive. Just because you buy from these merchants shouldn't preclude you from going and looking into getting a 3D printer for yourself. And if you do decide to get a 3D printer, that doesn't necessarily mean you should stop buying from these merchants. They probably have access to a lot more files than you're going to be able to get access to if you buy a 3D printer. And unless you plan on drawing in 3D yourself, which, have fun with that. That's it's one thing to learn Chitterbox and operate a printer. Drawing in CAD and Blender and Fusion and all those, that's not something that you just pick up overnight. And I won't even delve into it because I couldn't even begin to understand it if I wanted to. But it is important that you note that it's not a mutually exclusive thing. You should still, even if you buy a 3D printer, you should still peruse the websites of the merchants that I just listed and check out their stuff because they're constantly updating their catalog. And it might be something that you're not going to be able to get your hands on. So, knowing that, this episode, I want to focus on getting you through that first week of owning a 3D printer. Because that first week, when you're first starting out, once that thing gets delivered and you move things out of the way, you set it up, you get that thing, you'll go through the factory settings and follow the instructions that come in the box, or whatever the case may be. And then it comes time to print your first thing. And it'll print relatively well. Elegoo printers, they give you a bunch of files where you print a rook from a chess set. And it prints well. And you're like, all right, this is cool. So then you start slapping things on a build plate and Chitterbox, and the next thing, and you go to print it, and the next thing you know, it's printing, but I can't get it off the build plate. Or it's peeling away from the build plate, and I hear squishing and crunching as it's printing. So, wait a minute, what happened here? What happened? And then the next thing, you're cursing out Frank from Frank's Modelworks. That Frank Steffens, he told me to get a 3D printer. I'm going to kill him. Before you go there, I'm not gonna show you the path and then go, all right, good luck. Go get him, Tiger. I'm gonna impart what I know as much as I can to get you through that first week. Okay? So, the first thing you need to do after you set that printer up and you get your workspace all set up, you need to pick your resin, buy several bottles of it because you're gonna need it. And you're going to need to calibrate your resin. Well, what does that mean? Well, I'm going to show you. So the first thing you need to ask yourself is, what is calibration and why do you need to do it? A fundamental premise of 3D printing in resin is that the resin that we use is exposed to UV light in slices of a three-dimensional model. And as each layer or slice is exposed, then the resin is cured, building up a solid 3D object on your build plate. The exposure time that you're using for each one of those slices is going to dictate whether or not your model comes out underexposed, in which case it will be lacking in detail. You'll have adhesion problems to the build plate. Or if it's overexposed, overexposure generates heat, which causes expansion, which makes bigger models that don't fit. The parts won't fit together. So you don't want to be underexposed. You don't want to be overexposed. You want to find out what the right exposure setting for your resin that you're going to be using is, given the parameters that you're putting into your slicing program. Now, this is all kind of high-end stuff that is hard to get a grasp. I'm still trying to learn it myself. But one thing that I can impart on you, you should learn to calibrate your resin. Watch as many tutorials as you can find. There are tutorials on Scale Speed Garage related to calibration of pretty much every single aspect of 3D printing is covered, and that's why I recommend it so highly. But for the purposes of this video, I just want to drive homes in order to make that first week that much less frustrating for you. The point that you need to calibrate your resin. A lot of times, I go on Facebook groups and I see people posting pictures of their failed prints. And what happened here? One of the first things that the experienced people on that Facebook group will say is, "Well, did you calibrate your resin?" And the people are like, "What are you talking about? I don't even know what that means." So I'm gonna show you what it means to calibrate your resin. I don't know the nuances involved, and there's big rabbit holes you could go down in this, but I want to get you to a baseline so that the first print that you're gonna make on a 3D printer is gonna, if you buy an Elegoo, it's gonna be a ruck. It's what's loaded onto the thumb drive that comes with the printer, and that thing's gonna come out great. And you're gonna be like, "Wow, this is awesome. It's pretty easy. I don't know what Frank's talking about. He's full of soup. This is easy." And then you're going to go into Chitterbox and you're going to throw something that you just downloaded onto a build plate. You're going to try to print it and it's not going to work. And then that's when you're going to start cursing me out. I want to prepare you. And the first thing that you need to do, after you figure out where you're going to set this thing up and how you're going to, set up your workspace and purchase your resin and your peripherals and all that other stuff, you got to calibrate your resin. So the Saturn 4 Ultra has a really good utility for doing that. Now, calibrating your resin could take, like the file that I use is called Cones of Calibration version 3. It takes 39 minutes to print that. One. What's good about the Saturn 4 Ultra and the Mars 5 Ultra is that there's a utility within the firmware of the printer itself where you can print that file 6 times using 6 different exposure times. So that in one print, you're going to be able to figure out what's your best exposure time given the other variables that you program into your slicing software. So, let's take a look at that utility. Okay, we're set up over here at the printer. This is an extra build plate that I have, and I've labeled it, but we're not going to be looking at this right away. I'm going to use this for the purposes of explanation later on, because the dialogue itself for the utility is a little bit difficult to understand at first. And I'm trying to pan you over there somewhat smoothly, and I'm going to try to tighten you in. All right, hold on a second. So now let's get to the utility itself. This is the screen that you control the printer with right here. It is a touch screen. So in order to get to the utility for calibration, you'd go to Tool. You will scroll over one page and you will go to Resin Calibration. So now the first dialog that pops up is a 4 model resin calibration. My issue with a 4 model resin calibration is that I don't think it gives you enough shots at trying to narrow down. This would be a good test to use if you were using a small calibration file or if you had a larger build plate. For the calibration file that I use, Cones of Calibration version 3, the size of it itself is about that big, and you could just about get 6 of them on there comfortably, but 8 would be uncomfortable, and that's an option, and I'll get to that in a second. 4 is just not enough exposure settings to get a good baseline. This would be something where you're trying to narrow down between, say, for example, 2.5 and 2.0 seconds of exposure time. I would use that then. For this, for 8 model exposure time tests, my issue with this is, like I said, it's hard to get 8 of the Cones of Calibration models onto the build plate. And it's a pretty broad spectrum. So for that reason, I prefer to use... I hate it when I do that. You press this down here, it goes back to the 4, and now we're at the 6. Now, I had for the sake of demonstration, I'm going to set some values in here. But when I actually show you later on what the exposure looks like, I'm going to actually show you 6 second, 5, 4, 3, 2, 1. This way you can actually see the exposures going out on the screen. But for here, like a real world figure, when you first get the printer and you set it up, Elegoo has you set the default exposure time for 2.5 seconds. 2.5 seconds is a good baseline for most resins that you're going to use, especially if you're not going to be mixing resins and stuff like that. And I'm not getting anywhere near that topic because I don't know enough about it to even begin to guide you. So for the resin that I use Elegoo water washable resin. I just like its characteristics. I like the cleanup properties. I like being able to wash it with water, and then the way of getting rid of the dirty water that has the resin in it it just appeals to me. We'll leave it at that. That's a decision you're gonna have to make for yourself by weighing options and doing research on the matter. But as far as using this utility, so what you do is you start off. The box number 1 is in this corner. Box number 6 is in this corner. This is your lowest setting. This is always going to be your highest setting. So your highest exposure time is always going to be up here. Your lowest is going to be up here. When inputting the individual numbers, you should keep in mind, like say for example, I go to box number 4 and I put in 6 seconds, it's going to change every box before it to the highest setting to 6 seconds. Watch. See? So it just changed 4, 3, 2, and 1 to 6 seconds. So you have to, if it gets to be a pain in the neck. So let's say for the sake of argument, we're going to start at 1 second. Let's start at something reasonable, and we'll call that 2 seconds. Then we're going to make box number 5 2.1 seconds. And that'll keep that. We're going to make this 2.2 seconds. And it'll allow you to keep that. We'll make this 2.3. We'll make this 2.4. And we'll make this 0.5, and it'll allow you to keep it. So now you've entered a range of exposure times from 2 seconds up to 2.5 seconds. From there, you would then print out the file, which you would hit this play button, and you pick the, it's basically the only thing on here, the cones of calibration, which is the it's the only file that I have on here for calibrating resin. And click on it. Now, I don't want to hit print because I actually don't want it to print right now. But you would hit print, and then it would go through, you know, you get away from it, it's going to calibrate, it's going to calibrate the mechanical sensors on the printer, and then begin the print. Okay, so we're going to exit out of that. So what's important to realize is that this infographic is rather, and the interface is a little bit misleading, because box number 1 is the longest time. Box number 6 is the shortest time. And then by way of appearance, the way it's showing you that green box in the corner, and then you have the middle box on the bottom row, and then the right box on the bottom row, and then the left box on the bottom row, the right box on the top row would, well, basically it means, let me pull out and show you, that according to this build plate, and this is the top of the build plate, this is the way the build plate would face you while in the printer, up here. So the lowest print time is going to be at this position, but on the build plate here. Second lowest, third lowest, fourth lowest, fifth lowest, and this is going to be the longest exposure time over here. So the way that you can look at the build plate, like as it's printing, you don't need to know, but when you're taking the models themselves off of the printer, off of the build plate, you need to know what's what, because it's going to correspond to an exposure time, and you're trying to figure out which exposure time based upon the characteristics that you're going to observe in the models that you print. So I've made this for you. This is how the build plate is going to look. So you take the build plate. This is the part that's going to be facing you. As you take it off, you'll notice that there's spots for the rails to go in. Okay? Based upon the rails, you put your fingers in the rails. This is rough. Oh boy. It's rough because my arm is in pain. Sorry about that. So here you have, this part is facing you on the printer. So box 6, your lowest exposure time is going to be here. 5 is going to be here. 4 over to here, which is going to be your highest exposure time. Okay? And then from there, I'll show you how we remove them from the build plate and figure out what's going on. It all sounds so incredibly confusing, and believe me, if even I'm trying my best to make it sound easy. Once you do it a few times, it makes perfect sense. Right now, it just seems so overwhelmingly complicated, and it's because of the way that they made this interface. They should have made box number 6 the highest, because it's the highest number. And they shouldn't have given you an infographic that's referring to the top of the build plate, which you'll never look at. You'll only ever look at a build plate like this when you're trying to take models off of it. It's not like you're going to hold a build plate like this and try to take the models off the bottom of it. Who does that? Nobody does that. So that's why it's confusing. All right, hold on. Okay, so here's my settings within the Chitterbox environment. I'm going to open up the file for the cones of calibration. Okay, there's the file. Within the screen, within the environment, and you'll be taught all of this at Scale Speed Garage, but if you right click on your mouse and hold it down and drag the mouse, you'll be able to rotate and move the environment around so that you can move your model. So this is one individual model, and like I said, we like to print 6 of them. So that's selected. To unselect, you just click off, anywhere off of the model. To reselect it, you just click on the model, and then you'd go up to copy, however many copies you want to make. There's a dialog box which is fairly straightforward. I want to make 5 copies, so I have a total of 6. So here in the background, the bottom layers of a file are printing, so you might hear that popping sound that I was telling you about before, or later in this video. I don't know how I'm going to edit this. Nobody's going to watch it anyway. If anything, it's going to be trolls that are going to come in because they're going to see 3D printing and jump all over me. It's alright. I'll just ban you. Okay. So all 6 are on the plate. We're going to do select all. Go to slice settings. By default, Elegoo will have you set this up in Chitterbox. I changed the name to Water Washable 8K by Elegoo. They do have you enter the resin density, which is 1.1 gram per milliliter. The cost, this way you can figure out what your cost per unit is for each print that you do. So now this is what I changed in order to print out the cones of calibration. My layer height I have set to 0.025 millimeters. My bottom layer count, which bottom layers are being printed now on my printer, which is why it's making the sound, is 5. My exposure time, not the bottom layer. The bottom layers will be exposed at 24.5 seconds. That's down from the default, which is, I believe, 30 or 35 seconds. Like I had said, I like to keep my exposure time and my bottom exposure time in the neighborhood of 10%. So if my bottom exposure time is 24.5, I like to be in the neighborhood of, like I wouldn't make my bottom exposure time 30 and then have a layer exposure time of 1.8. It could be a differential in exposure that could wind up cascading into the print and cause a problem for you. Transition layer count I have kept as default, as I was told to set it when I first got the printer by Elegoo. Transition type is linear. This number, which is blacked out, is the transition layer interval time difference. That's a function of the exposure time to the bottom exposure. I don't know, something like that. I can't change it by myself, so I don't care. None of this stuff I touched except for this. This is actually the reason why I did the print of cones of calibration. I wanted to try the anti-aliasing. By default, it defaults to none. You can do grayscale. I don't know what that means, whatever. But I wanted to try with anti-aliasing to see how that would change the prints. And I set that to 4 on a scale of 2 through 8. So I figured I'd hit the middle if I'm going to do it. And adjust the anti-aliasing effect of the print model by setting the exposure time level of the image edge in the printer in the print layer. Only applicable to printers in CBD DLP slice format. Well, I don't think that's what mine is. Whatever. I've printed a couple of things with this so far, and it hasn't really. I haven't noticed much of a difference. So with that, I'm going to hit apply. It's going to save those settings. And then once you've done that, you can keep those settings. You don't have to change the slice settings every time that you slice something or you're going to print something. In the environment, if you find yourself like in a wonky position and it's hard to, like, you zoom in and you're like, where am I? You can always go up here, hit home, and that'll bring you to where, and then you can click over here, top, move it around to the front, move it around to the bottom, move it to that way, just using the arrows. So home and top is gonna be one of your more common ones. So in order to slice it, you hit slice, it'll do its thing. Just taking its sweet time. Now this file is designed to print unsupported directly onto the build plate. If we really wanted to, it's designed to be printed directly onto the build plate, and if we were going to do that, I'm not going to be able to send it because the printer is actually running right now, but this is the dialogue. So right now it's telling me that the printer is busy. If I wanted to send this via Wi-Fi, I would select the printer, it would highlight, and then I just click send. It's going to save a bitmap file of this little thing going on right there, and then it would Wi-Fi send the file over via Wi-Fi to the printer. Another feature that you have within ChituBox is Chitu Manager. That's up here. You click on that, and it's going to allow you to select your printer. So this is what I'm printing right now. This is a Scale Speed Garage file. And if you want, you can turn on the camera. How you doing? I'm over here. So if you watch, you're gonna see the vat tipping away from the build plate. So that'll give you a pretty good idea of what's going on when I talk about vat tilting. You see the z-axis of the build plate moves. So now when I was describing the disturbing sounds, if you hear those disturbing sounds now, that's a problem. But if you hear them now, it's not a problem, because it's, if you hear that sound while the vat is tipping away from the build plate, it's just a normal sound that the PFA will make because of the higher exposure of the bottom layers. If you hear it while it's coming up, that usually means that there's some cured resin getting stuck between the PFA film, the LC, and the build plate, and that could damage your PFA film. And if that is breached, then all of that resin is going to leak out onto your LCD screen and probably do serious, if not complete, total damage, destruction to your printer. So maybe you want to keep an eye on this, and maybe you don't. It's just something to keep in mind. It's a feature of the actual printer itself that I happen to like, and I think it's a good feature. So there's Chidu Manager within Chidu Box and my settings. As far as the tutorial on working in Chidu Box, that's covered by Scale Speed Garage, and I really don't want to step on Chris's product, so that'll be the extent. I will go, go as far to say it is a fairly straightforward interface of selection, movement. You can either move through entries in this dialog box, which is a little bit wonky, with the exception of maybe lifting it off the build plate. This is rotation, so you can rotate a model. There is an undo button up here on top. You hit that, undo. And there's also a scale. So right now, this is 100% of the model size. You can print this bigger if you want. Makes it bigger. Brings it back. So if you are ready to print this, like I showed you, you'll select all of them. You'll slice it, and you'll go through that sending procedure. Once you send it over to the printer, then in the next video, I'm going to show you how to get ready to print. So hold on a second. We're going to sum this up, or depends on how I edit this, but I will be talking to you momentarily. I've removed, as you can see, I've removed the build plate, and the resin vat is also over here. Here's the build plate on top of it. When you buy a spare resin vat, by the way, you get a nice little cover that doesn't come with the printer, because they don't have the room for it while they're packing the printer itself. But if you buy a spare resin vat, you will get a cover that you could put over, just so you know. Going through the calibration file, the build plate will come down, and this is actually one of the features that's pretty cool about the Saturn 4 Ultra. It's giving me a warning right now because it's detected not enough resin, which is kind of accurate because there's no resin. But it also has the ability to let you know if there's too much resin. If you fill your resin vat up past the max line, it will stop printing. It won't even start printing. So that's actually a pretty good thing. Another feature that's good that I told you about in Chitterbox is the AI camera. There it is right there. You can monitor your prints. Is it yelling at me? All right, relax. I'm talking to somebody. You can monitor your prints as they're going on. You won't really, unless you're printing something pretty tall, you're not really going to see much in the way of progress. But what you will do is see the vat dipping in. So that will let you know that the print is ongoing. So there is technology in this printer to detect failures. So that's good for you to know. I'm gonna try to get this thing started. It does do the exposure, the bottom layers, so they expose for like 25 seconds. So I'm gonna let it go through all of that, and then bring you back in when it's actually flashing the individual models of the rafts that I showed you for the cones of calibration. So once that's actually going on the screen, and you'll see they'll go out in order. I've actually set it for 1 second, 2 seconds, 3 seconds, 4, 5, and 6. This way you can actually see the direction, and you'll see how it would line up with the orientation like I showed you with the numbers on the build plate. All right, so hold on a second. I'll be right back. Okay, so now we can see the exposure is going to come on, and then they're going to go off in order. Now, you see the screen is tilting down. That's what makes the vat tip away from the build plate. And that's the feature of the vat tilt. So now it's in exposure setting. It's going to rest. It's going to come back up. The light's going to come on. 1001, 1002, 1003, 1004, 1005, 1006. Just like I said it. So that's what you are dealing with when you do a resin calibration. Hold on a second. So here's the vat in place. Take the cover off. Again, this cover comes if you buy a spare vat. I don't think they sell the cover separately. Make sure you put your thumb screws on your resin vat. It is not good if you do not tighten them. Okay, so this thing's ready to print. How's my resin level? Oh, sure, plenty. I like to keep my, when I start a print, as long as it's below where it says max on the resin vat. See if I could bring it in tighter. Stellar camera work, Frank. Right there it says max. All right, that's I don't like to, there's a line in the middle of the X, so I could put a little bit more in, but I don't like to mess around, because it's gonna stop. It will stop anyway. If there's too much resin in there, it'll cancel the print on you. You'll get a warning, and you'd have to empty it out. If you ever do overfill it, get one of these cups. You probably get them on Amazon. A little cup that has a spout, so you can fill it up and then just pour it, strain it through a strainer into your bottle of resin. Don't try to, because if you just take it off and then try to just dip it out through here, which is fine, or dip it out over here, there's two, let me bring it back out. There's two spouts on the resin vat. It gets messy and then it'll drip a little down here, and it's just more cleanup for you. So just get one of these cups on Amazon. Alrighty, we're over here at the printer. We're ready to get the 6 prints of the cones of calibration off the printer and look at our results. Make life easier. Go into tools, manual, return to home. Before I do anything, I'm going to put my drip tray in place. Notice I'm wearing gloves. That's a safety. That's for safety. Uncured resin is pretty nasty stuff. You could develop an allergic reaction, almost like a contact dermatitis to it. So just to be safe, wear gloves. These are 8 mil. Alright, so we undo the latch that holds the build plate on. Okay, get this little shop towel ready. There's a maneuver that you make so that the excess resin, because there is going to be resin on top of the build plate that's going to drip off. So there's a maneuver, you flip it down, you tilt it to one way, this way it all pours right back into the vat. There's less cleanup that way. Just you got to be a little conscious of what you're doing. Alright, here we go. You want to be real careful holding the build plate where it is now, because if you drop it, one corner of it's going to go right into your PFA film and your LCD screen, leading to a really, really, really bad day. You're going to want to get as much of that to drip off as possible. And then take this shop cloth, get it there, and just move over. I'm moving over to where I do my cleanup. Okay. I didn't have any spills, nothing in the drip tray. First time for everything. So move my drip tray out of the way, move the lever down because you can't close the hood with the build plate all the way up in the Y-axis. You just move the lever down and then you put down the hood. This way no dust gets into your resin vat. Alright, let's go over and take a look at how these little sleds of cones of calibration. Let's see how they look. Done. Okay, so I made up this little piece of paper so that when I've already taken them off the build plate and started washing them. That'll be in my workflow video, how to do that. But what I'm trying to drive home is the importance of calibration and why I use cones of calibration. It's actually kind of fun. Makes a little mug and with beer in it that you can then, and a sword that you stick to a skull that becomes part of a figure. It's all a thing. Check out the link in the description. But I made this piece of paper based upon the build plate, how it's going to look to you when you're looking at the build plate. So shortest, next, longest exposure. Okay? And that's how it... That, if I move you over to here, is how I laid out the little prints right there. Pardon the shaking of the camera. One of them is missing because it's actually in the tub washing. Just finished washing it. So I'm going to go through the process of washing them. I'm going to arrange them on that piece of paper that I just showed you. And then when I'm done, we're going to take a look at it, okay? Hold on. So what does all this mean? I don't know. It's what I just did was I had changed from the default settings that came with the printer because I wanted to get slightly smaller layers. Out of the box, the manufacturer recommends that you print at a 0.05 millimeter layer. at 2.5 second exposure time. So I wanted to move away from that because I wasn't exactly pleased. I was starting to see like build lines, and you know, I was getting successful prints, but I wasn't necessarily getting what I was after. So I started to tweak, and that's what you use the calibration. You know, you experiment, you try to find the optimum exposure for the resin that you're using, also within the constraints of the settings that you're using. So what I did first was in Chitterbox, which is the slicing program that you slice the 3D models that you download onto your computer. You slice them into little layers that are then printed by the printer. And out of the box, they, like I said, they want you to set 0.5050 for the layer thickness. They want you to have 5 bottom layers. Out of the box, I believe they want you to set the bottom layers to be exposed for 35 seconds, which sometimes leads to problems. The longer you expose something, the more problems you have with adhesion, and you could wind up getting things stuck to the build plate where you won't be able to get them off. They'll shatter when you do try to get them off. So one of the things that I've learned along the way, as far as my bottom layers, they should be in the neighborhood of 10 times my exposure time. So let's say, for example, I have an exposure time of 2.5 seconds. I want that in the neighborhood of 25 seconds. The reason being is, like I said, you don't want things getting stuck to the build plate to the point where you can't get them off. And if you keep that exposure time for your bottom layers at 35 seconds, especially with the resin that I use, you could have adhesion problems where it adheres too well and you're not going to be able to get it off. Now, the opposite side of that coin is if you don't expose things long enough, they might not stick to the build plate at all, and you might just have a glob. So when you venture away from the factory settings, you want to take small steps and experiment along the way, and realize that this is a process of experimentation. And given the tools from Scale Speed Garage, you could do so more confidently. So what are we looking at here? Well, what we're looking at is a sled. This is a nice little designed 3D object called the Cones of Calibration by a Tableflip Foundry. They put this out to make it easier and actually kind of fun to do your resin calibration. So the first things that you look at when you're looking at the cones of calibration after you've printed them and you've cleaned them and you've given them a little bit of time to rest, is the first thing you do in order to rule out is you look at your cones of calibration. You have index cones. So in here, let me see if this is, yeah. Right here you have a plus sign. This is the success side. So there should definitely be a connection between the bottom and this cup in these two positions, okay? So, like I said, you have the index, there's a positive sign, a plus sign on the success side. So on the success, you should expect to see a connection, like the stem of this word, a goblet, or a champagne flute. The stem connects the base to the flute, to the cup itself, okay? Now the other side of that coin is the failure side. It says failure, and these have two negative signs right here at the base of these flutes. So the failure should be, these should definitely fail. And what I can see is they did not fail. So on its face, this setting, exposure setting, failed. So this was the longest exposure at 2.5. What that's telling me is, for this resin with these settings, it's overexposed, which is why it expanded and it's touching. It's still touching the base over here. So this one on its face is no good. So this one's ruled out. You could still use it, but I'll show you the other tests that you do. Okay? So now, having shown you the features, we could look at this one. My success side is good on this one. My failure side, I have one of them broke loose, but one of them reached out and is still touching. So no good. That one's 2.45. That's no good. Given these settings with that resin. So 2.4, success is all good. Failure is all good. Look, they both failed. The index cones failed, which is good. That's a good sign. Let's flip it around. My success cones are good. So that's not bad. If you look at the bottom, you could see the texture, the laser texture of the build plate. So this wasn't difficult. None of these actually were difficult to get off the build plate. So I like my bottom layer exposure time of 24.5 seconds. I like that with the 0.025 millimeter layer. I like that. 5 bottom layers with 5 transition layers so far. So this one we're gonna investigate further. At 2.4. This one, my failure, nope. This one for some reason, even though that's weird. This one is the failure cones, the index cones did not fail. So, we'll keep it for investigation. The success cones are all there. So, this one, I'm going to say because the success cones didn't fail, the failure cones didn't both fail, the index cones, I'm going to say that's a failure. Let me just make sure. Stand by 1 second. I'm back. Yeah, I just checked on Tableflip Foundry's site. That is weird. So if there is something, if in your index, your positive success or your negative failure, if you have something in there that's not supposed to be there, so these are supposed to fail and they didn't fail, so this is definitely a no-go. So this 2.4 could have been a fluke, but we'll look at other things. There's other things to look at in order to continue your evaluation. So now 2.33 seconds, we got an index failure, which is good. You can see there. And we got success, all of them printed, which is good so far. So we'll stick with this. And this one, which was 2.30, all of my success cones were good. All of my failure cones failed, and especially the index ones. So now we have these three to investigate further. So there are other things that you can investigate. First off, you look in this window right here, and all of these little lines in here should print clearly. And the one all the way over here towards my left hand, failed. So right there, that's for me, that's eliminating. But it's not necessarily a damning thing. You should definitely, you know, like it I'm probably going to rule out 2.4 anyway, but that little wiggle in the print resolution right there, I don't like that. So especially, we'll check the other ones. If the other ones don't have that and they're really nicely printed, then we can eliminate that. So we'll put that. So far, this is looking eliminated. We'll go to 2.3. So this one has a very, very slight wiggle in the finest line over there. If you could see that. Very, 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 very slight. And this has like this right here is supposed to be a darker line fading away to infinity, as you can see, and that's looking pretty good. So this one, I'm going to consider this still in the running. So let's look at this one, which was exposed to 2.30. So 2.30, it collapses. This little line here collapses. The infinity looks good, but it's starting to look like 2.33. But there's still more tests to do. And this is where it starts to get a little bit of fun. So what you do is you break this off. This is ale. This is 3D printed beer. You break it off. And take that and you break off this little empty mug. And you take the ale and you put it in the mug of beer. Now this is not going in. So that means that this is overexposed. This part is too big to go into here. So the test failed. And that's why it's important to do all of the tests on there. Jeez, I hope the other two make it. This is not looking good. But to confirm, there's also another part of the test. You pull out the sword from the center here. Like that. And you stick it in the no-go holes. So it is supposed to stop. It's not supposed to make it through, but it should fit perfectly inside this skull right here. I know, it's a bit much. So let's see. And it's stopping. So this failed. This is supposed to go all the way through. There's even room for it. So this is an overexposed model. Perfect example of why you calibrate your resin. So, for the sake, one last test that you could do to test dimensional accuracy is that this is supposed to be 6 feet wide. This little box here is supposed to be 6 feet wide. I'm sorry, 6 feet. 6 millimeters wide and 6 millimeters high. So I have my calipers here. And they're not super precision. They're not expensive, so we'll see. So dimensionally here, it's okay. It's not that bad. This actually printed okay. As you can see, 6 millimeters. So, unfortunately, this has been ruled out. So let's check out this one. Break off the ale. Break off the mug. So now this looks like it's gonna go. And it does, and it fits really, really well. Okay, so that's looking good so far. Let's get out the sword. We'll try the go, no go. It's not going. Now let's see if it goes through the skull. And it goes. So that skull, this is 2.33 is good. Now that, you know, those little marks, not really a big deal. Ooh, sorry. And the one last thing we could check is the dimensional accuracy. So we're pretty much okay there. And we are pretty much okay there. I mean, within 200ths of a millimeter. That ain't a hair your buddy Frank is gonna split. Let's look at the last one, the 2.30. It fits. Doesn't fit perfectly though. Very strange. I didn't mix them up. I made sure I took them off the same. But results are results. So let's take a look. And it does go through. So the optimal, based upon these tests, these are obviously the two best results. This one was as close to perfect as possible. Because of the slight tightness, when I enter this as a layer, as an exposure time in my in Chitterbox, I'm gonna enter this as 2.325 seconds. Just for, because it's a little bit closer to underexposed. Oh, the other thing I was printing just finished. Wait, I forgot to show you puck. So now what do you do with this information? Well, you don't just throw this stuff out if you don't want to. You can use it. Here's the mug. Here's the beer inside. Here's the sword. And what you do is you could print out, he comes with the file, the Cones of Calibration file. This is Puck the Adventurer from Tableflip Foundry. And this is free, by the way. You print him out. He's holding his beer. Comes with a little base. There's the skull that his sword goes through. And he stands on it. And you got a nice little miniature that you could paint if you want. Look at that. That's pretty cool, right? And it's free. There's actually a lot of free files. It's going to be one of the episodes that I do about downloading files, where to get them, and stuff like that. It's an entire world is going to open up to you. All right, hold on a second. So at the end of the day, it's a lot more fun, especially the ending. You know, going through the results and actually seeing physical results of the inputs that you make is rewarding. And at the end, you're rewarded with a little miniature that you can paint and maybe even branch out to a new sector of the hobby. Maybe not. So I hope with this video, I take a day off of your week of frustration. And I think I might take more than that. Printing without calibration is an incredibly frustrating experience for a lot of people that get into 3D printing. If you don't calibrate, you're going to have problems. If you just go by the settings that they give you, then you should buy the resin that they tell you to put in there. But, you know, that might not be the best choice for you, that resin. You should decide your resin on it based upon the characteristics that you want to produce, but then also the workflow of cleaning up. This could be a messy endeavor, and it's not like you could just take uncured resin and pour it down your drain. Don't ever do that. Don't ever do that. It's dangerous. It's bad for you. It's bad for the environment. But it's bad for you. It's bad for your house. Okay? Don't do it. Don't do something stupid. So that's why that's one of the reasons that informed my decision to go water washable. I'm gonna find a way to make this stuff work and work well. Okay? Come along for the ride. So, to sum up what we went over, now, an hour long, I think it was at about an hour and 5 minutes before I even recorded this. But you know something? Like I said, your first week is going to be a swift pain in your neck if you're not tuned in to what you got to learn before you start trying to print. Okay? Part of your week of frustration is going to be figuring out where to put all this stuff, and then have a way to vent and ventilate your work area so that you don't have noxious chemicals. You know, that's something. And then you have to figure out so you could plug it in. You know, there's considerations, and then there's also frustrations associated with that. So you gotta take all of that into account, and then subtract like things that you can mitigate the frustration. And I hope that that's what this video is going to do. Is going to show you a unique feature for this printer, the Saturn 4 Ultra. Everything that I discussed in this episode is also applicable to the Mars 5 Ultra from Elegoo, which is a much lower price. The Saturn 4 is about $499, and the Mars 5 Ultra is about $270. I might be getting one for Christmas. From me. 'Tis the season to be selfish. Fa la la la. Sorry. But that's another thing. Once you make the initial investment in the peripherals that you might buy, like a HEPA filter or the cleaning tank or the curing station, you could, every single printer that you buy that's a resin printer is going to be able to use all that stuff. It's going to be applicable. And then you can, it's a matter of do you have the room? Do you have the electrical capacity and stuff like that? But you could start up your own little print farm. I'm just spitballing. I ain't paying for none of this, so you do what you got to do. The decision to buy the printer is on you. The decision of what printer to buy is on you. But then after you've done that, I want to try to inform some of the decisions that you make and make it easier along the way. So with that in mind, please stay tuned for part 3 in this series, where I'm going to go over my workflow. I'm only 3 months into 3D printing, and I started, I think, in the beginning of September, and I was still hampered by my injury. So it was, I call it a frustrating, well, other people call it a frustrating week. For me, it was several weeks because of what was going on in my life at the time. But I don't let silly things interrupt my birthday celebrations, my birth month celebrations. So, once you do get the hang of it, though, there is a measure of, and this is a word I use a lot, catharsis, relief, happiness, enjoyment in developing a new aspect of the hobby and becoming a part of a new hobby unto itself. So it's worthwhile in the end. So like I said, stay tuned for episode 3. And there's probably going to be an episode 4, 5, and 6. Let's see where this goes. But try to keep my recommendations in mind. Please check out the links that I'm going to have in the description. And especially check out Scale Speed Garage. I think it's worth the investment. And it is an investment. It's not an expense. It's an investment. And it's going to pay dividends in knowledge, expertise, a community, really, really expert advice, and the files. let me tell you something. These things are nice. There is some really talented people drawing up these files. So, really give it some serious consideration. But until then, as always, I got Frizzo's back. I appreciate your support now more than ever. And until we speak again, my friends, take care of yourselves and be well.